Hey, did you know that every single whole number out there has a secret code? I mean, a hidden identity that's totally, completely unique to it? Well, today we're going to become number detectives. We're going to learn how to crack that code. So let's dive right in. What exactly is this secret code? We're not just talking about some random string of digits here. No, it's something way more fundamental, something that really defines the very essence of a number. And here's our game plan to become master code breakers. First, we'll meet the atoms of the number world, their basic building blocks. Then, we'll find out what this secret code is all about before we learn two super powerful methods to crack it wide open. And finally, we'll see what makes this code a truly unique fingerprint for every single number. All right, first things first, the atoms of numbers. Look, to understand the code, you've got to understand the language it's written in. And guess what? That language is made up entirely of prime numbers. So, what even is a prime number? Okay, think of it like a single solid building block. You just can't break it down into any smaller whole number pieces. The only way you can get a prime number, like say 7, by multiplying is, well, 1 times 7. That is it. It has only two factors, 1 and itself. It's basically indivisible. Now, this is where it gets really interesting. On one side, you've got our primes, those indivisible atoms like 2, 3, 5, and so on. But on the other side, you have composite numbers, and these are like the cool, complex structures you build from those basic blocks. Take the number 12, for example. You can make it by multiplying 2 times 6 or 3 times 4. See, it has more than just two factors, which means it can be broken down. Okay, so now that we know our building blocks, let's finally talk about the code itself. And this, my friends, is what we call prime factorization. The prime factors? They're simply the specific prime numbers, those atoms, that you multiply together to build a particular composite number. It's kind of like a recipe, right? What prime ingredients do you need to cook up the number 12? Well, you need 2 2s and 1 3. And this is the most important rule of the game. The key takeaway is that this recipe, this prime factors, is completely unique for every single composite number. The number 12 will always break down to 2 times 2 times 3, every single time. No other number has that exact same prime recipe. It's one of the fundamental laws of math. It's incredible. So the big question is, how do we find this unique code? Let's check out our first master key, the factor tree. This is a really visual, really intuitive way to get it done. Okay, mission accepted. Our target number is 48. We're going to break this thing down and find its secret prime code. Let's do this. The first step, super simple. Just find any two numbers that multiply to make 48. Here we went with 4 and 12, but honestly, you could have picked 6 and 8, or even 2 and 24. It really doesn't matter, and you're about to see why that's so cool. Okay, now we look at our new numbers, 4 and 12. Are they prime? Nope, not even close. So we break them down again. 4 becomes 2 times 2. And since 2 is a prime number, we circle it. Boom, that branch of the tree is done. Now, 12 becomes 3 times 4. We circle the 3 because it's prime, but wait, 4 isn't prime, so we have to split it one more time. So as you can see on the completed tree, we just keep going until every single branch ends in a circled prime number. And there it is. The secret code for 48 is all those circled numbers multiplied together. We've got 4 2s and 1 3. That means 2 times 2 times 2 times 2 times 3 equals 48. Code cracked. But what if you're not a fan of the whole tree thing? Maybe you like things a little more linear, a bit more orderly. Well, there's another master key for that. Let's take a look at the division method. This method is just so systematic. You start with your number, and you just keep dividing it by the smallest possible prime number that'll work. Then you take that answer and do it again and again, and you just keep repeating the process until you finally get all the way down to 1. Let's run 48 through this method. What's the smallest prime that divides into it? That's 2. Okay, 48 divided by 2 is 24. We can divide by 2 again, we get 12. Again, we get 6, and one last time to get 3. Finally, 3 divided by 3 is 1. We're at the finish line. So what are our prime factors? Just look at all the numbers we'd used to divide with on the side there. 4 2s and a 3. Look at that. It's the exact same code. So let's just pause for a second. We've used two totally different methods, but we ended up in the exact same spot. What does that tell you? It tells us that this is no accident. It's not a coincidence. This prime factorization, it's a fundamental property of a number. Just like your fingerprint is unique to you, The product of a number's prime factors is unique to it. It's literally its mathematical DNA.
And you might be thinking, okay, cool, but why does this matter? Well, this simple idea, these prime numbers, are at the very heart of some of the deepest, most complicated, unsolved problems in all of mathematics. Just like this quote says, even with all our computers, we can't predict where the next prime number will show up. It's a huge mystery, one that connects to things like the Riemann hypothesis, a $1 million prize problem. So the next time you look at a number, just remember, it's not just a digit. It has a secret code, a unique fingerprint, and it's connected to some of the biggest questions we have yet to answer. Makes you wonder, what other secrets are numbers hiding?